Hello friends, this video on electrochemistry part 24 is brought to you by examfear.com. No more fear from exam. So here we have to find lambda m naught, that means molar conductivity at infinite dilution for CaCl2 and MgSO4. We'll use this table. So if you see lambda m naught for CaCl2 as per Kohlrausch law will be lambda E naught of Ca2 plus lambda m naught of Cl minus, and there will be 2. Why? Because CaCl2 it will dissociate into Ca2 plus ion and 2 chlorine ions. So let's put the values here. That becomes Ca2 plus 119 and 2 into chlorine Cl minus 76.3. What is the unit? Siemens centimeter square per mole. If you solve this, you get this becomes 152.6 plus 119, that is 271.6 Siemens centimeter square per mole. Correct. Let's do the same thing for MgSO4. So if you see MgSO4, it will break into Mg plus 2 plus ions plus SO4 2 minus ions. Correct. So if you want to find the lambda m naught of MgSO4, so as per Kohlrausch law, it will be nothing but lambda m naught of Mg2 plus lambda m naught of SO4 2 minus. So what is the value of Mg2 plus? This is 106, SO4 2 minus 160, and the unit is the same guy, Siemens centimeter square per mole. So if you solve this, you get 266 Siemens centimeter square per mole. Pretty easy. The next question is the lambda m naught for NaCl, HCl and NaAC are given. Right? We have to find the lambda m naught of HAC. See, NaCl will break into Na plus Cl minus. HCl will break into H plus Cl minus. And NaAC will break into Na plus AC minus. Right? So if you want to find the lambda m naught of NaCl, will be nothing but lambda naught of Na plus lambda naught of Cl minus, and that value is given 126.4 unit is given, that is S centimeter square per mole. Similarly, lambda naught of HCl is given, that is nothing but lambda m naught of H plus lambda m naught of Cl minus, and that is given 425.9 Siemens centimeter square per mole. Similarly, this is given lambda naught of NaAC is given, that is nothing but lambda naught of Na plus lambda naught of AC minus, and that is given 91.0 Siemens per square mole. This is equation 1, this is equation 2, and this is equation 3. Now if you just see, if we add these two equations, second and third, if we add these two equations and then subtract the first equation, what will happen is we'll get lambda naught of H plus, Cl minus, Na plus, AC minus. And from this we are subtracting Cl minus and Na plus. Correct? So these two will go off and these two will go off. So what I'm doing is I am adding 2 and 3, and from that we're subtracting the first equation. Right? So what I'll get is the whole equation I'll be getting is lambda m naught of H plus lambda m naught of AC minus, and that value I'll getting is this plus this, right? 425 plus 91 minus 126.4. If you solve this, you get 390.5 and unit will be S cm square per mole. And this is what? This value is nothing but lambda m naught of HAC, because HAC will break into HA plus AC minus. Correct? And that's what we are able to find the lambda naught. See, just three equations. It's quadratic equation. You have to just reframe this equation to make sure that you get the value of molar conductivity of HAC at infinite dilution. The next question I have is the conductivity of some mole of acetic acid is given. Right? We have to calculate its dissociation constant. That is, we have to calculate the alpha and K. If lambda m naught is given, correct? See, to find the value of K equilibrium constant, I have to find alpha, and alpha is what? Lambda m by lambda m naught. Correct? This is at infinite dilution. This is at any concentration. So lambda m naught is given to us. This value is given to us. I have to find first my molar conductivity at this concentration. For this, the conductivity is given, K is given, and C is also given. So lambda is nothing but K by C. So I can easily find this value. Once I have the lambda m, I have lambda m, I can find alpha. Once I have alpha, I can find K equilibrium constant. Right? So this is for the acetic acid. So the equation is I have CH3COH. It will become CH3CO minus and H plus. Right? I'm assuming C is my initial concentration, and after equilibrium is reached, this becomes C alpha and this becomes C alpha. So my K will be what? C alpha square by 1 minus alpha by C alpha into C alpha by C1 minus alpha. We have seen this so many times, so I just wrote this because this is nothing but concentration of CH3CO minus into concentration of H plus by concentration of COH. So I need to find first what? As per my discussion, I have to first find lambda m. So lambda m is what? K by C. Lambda m naught is given in Siemens centimeter square per mole. So we'll try to find the lambda m also in this unit. So what is the value of K? K is given. Conductivity is given. This is my K and this is my C. K is my K. That is 4.95 into 10 to the power minus 5 Siemens per centimeter. This is mole per liter. So this is 0.001028 moles per liter. Liter I'll make it 0.01 centimeter cube, right? 0.1 centimeter cube, yeah, sorry. Right, 1 liter is 0.1 centimeter. So with this I'll get in the same unit. So if you solve this, you get 48.15 Siemens centimeter square per, that is the value of lambda m. This is I have lambda m naught is given, right? I can find alpha. Alpha I have seen that by Kohlrausch law is nothing but lambda m by lambda m naught. Lambda m we just found 48.155. This is 15 Siemens centimeter square per mole. This is all my unit. Divide by this value 390.5 Siemens centimeter square per mole. These two units gets cancelled, and this value you get is 0.1233. Once I have alpha, I can easily find K. K is what? C alpha square by K is C alpha square by 1 minus alpha. Let's put all the values. C is what? C is given. That is in 0.001028, and C, please note, here will be in molarity, moles per liter. it will not be in moles per centimeter cube or moles per meter cube, and the alpha is 0.1233 square by 1 minus alpha, that is 0.1233. So you solve the values, you get 1.78 into 10 to the power minus 5, and unit will be obviously moles per liter. Why? Because this is unitless, this is unitless. So the unit of K equilibrium will be nothing but the unit of molarity, concentration in molarity. This is moles per liter. The next question is, the resistance of a conductive cell consists of 0.01 m KCl solution at 298 Kelvin is 150 ohms. So this is my resistance, this is my resistance, this is my concentration, this is my temperature. What is the cell constant? Is the conductivity of the same concentration. The concentration is same, if you see. Add this is this. So this is my conductivity. Conductivity is what? K. Right? The formula I know is R is rho L by A. This is the formula I know. But rho is not given, K is given. I can say it's nothing but 1 by K L by. Correct? So in this case, let's see what all given. Resistance is given, yes. Conductivity is given, yes. And what is the cell constant? This is cell constant, right? So let me make it G star only. So the formula I'm going to use is R is equal to 1 by K G star. So the point I'm trying to say here is, I don't remember all the formulas. I just remember this formula, R is equal to rho L by A. And then based on whatever is given, if my conductivity is given, I'll make it 1 by K. If my L by A is given, I'll make it G star, right? So I don't remember all the formulas. I just remember one formula, R is equal to rho L by A. This is the formula I'll be using now. So, correct, I have to find what? Cell constant, G star. So my G star is nothing but R into K. What is the value of R? 1500 ohms. What is the value of K? K is given this value, 0.146 into 10 to the power minus 3 Siemens per centimeter. Siemens and ohms gets cancelled. You solve this, you get 0.219 per centimeter, and that is my cell constant. If you see, cell constant is L by A. So it's, if you put length in centimeter, area in centimeter square, unit will come out to be 1 by centimeter, and that is the unit. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.